of ambient conditions like humidity and temperature, and operating in a specific range of current and voltage.
Right.
And so if you exceed those normal ranges, you're going to decrease the health or the lifespan of that transformer over time.
Jeff, I apparently had not hit the button.
No shit.
So what you're talking about again is these really big transformers. They are submerged.
It's not necessarily really big.
They don't have to be huge. I mean, so we're sitting here at a table at Buffalo Wild Wings. A smaller one could be, roughly the size of this table to the floor. I mean, a larger one, and I've seen big ones, might be the size of, if you got like a F350 or something. Maybe a little taller, but they can be very large too.
Well, a lot of times you can have the smaller ones and be in a sequence, like 3 or 4 in a row to generate the same kind of conductancy of one big one.
Yeah, usually what they'll have is, so you have your utility power coming in, and it's at a very high voltage, but you can't use that high voltage, to run your equipment.
You have to tame it down,
You have to drop it down. So they'll have usually one large transformer, and the higher the voltages are, the more likely you're going to have some type of oil or gas-filled transformer, because it's a much better conductor.
Exactly.
When you get the lower voltages, usually they're just open-air transformers.
Right.
But yes, coming in from the utility, you're going to have either, could be very large, could be a little smaller, but it's going to handle higher voltages. And you'll typically drop that down on any given site to, something like 30 kilovolts or 15 kilovolts. If it's a smaller site, maybe you drop it down to just 1500 volts.
Yeah.
But sometimes, like you said, if it's a really big site, you may have several stages of step down.
Right.
Now, and the reason why you want to do that is because the higher the voltage is, the less current you have to send through that line.
Exactly.
So you can run longer distances. So if you've got a really large site, and that's why you see the utility lines being so high voltage. You can run it for a long way.
Right. And like in what you're talking about, like a lot of times it'll be coming off like a substation. Mm-hmm. Like you got a substation here to boost the power. Well, then you've got to increase your transformer capacity to delete that power as it goes through the system.
Yeah, and it's all based on your load calculations. Mm-hmm. So when you're designing your
if you're in an industrial
facility,
park versus a subdivision, it's a big difference.
Oh, absolutely. Yeah. And the utility companies, they have their own substations, but they have predicted what the usage is going to be in any given area. Right. So when you, as a company, decide to tie into that electrical grid, you can't just tie into it willy-nilly. I mean, there has to be a decision made to make sure that they're not putting too high of an increased burden, both for the amount of power and energy you're going to consume, as well as the quality of that power.
Right.
Because if you degrade the quality of the power on the line, it's going to affect everyone on that same segment.
And I think throughout America, we see that on a day-to-day basis. You don't realize it, but you just look. You're sitting at home, you watch TV, all of a sudden your lights flicker.
Yeah.
And case in point, what Jeff's talking about, it's like, it's a fine line between what you're supplying versus what demand is needed. And certain times of the day, the load is heavier than others.
Yeah, or if you live near a dam, for example, and they don't have some type of stabilized startup procedure. If for some reason that were to kick in quickly, you're going to see a huge sag on that particular grid. And sags are very dangerous because your equipment, especially motors or drives, something that is a sensitive, almost always critical equipment, if it dips below the acceptable voltage range, you could easily damage that equipment. Or if you have assembly lines or some type of process within your facility, it could damage that equipment, and more importantly, could damage or harm the people in your facility if that equipment operates erratically.
You've got engines, electrical engines that are designed to run upon X amount of voltage per hour, and then you deplete that. It's just a matter of time if that engine gives up. It's like, I don't have enough to run on, so I can't do it anymore.
Right.
All right, let me break it down a little bit. How does a construction contractor need to consider this? does he even need to know anything about the
Depends
power
on-
needs of the structure?
Depends on what kind of field you're in. If you're in the mining and quarry business, this is a big ordeal. I mean, you're talking, 3-phase power day in, day out. And not only, to run your machines or your equipment, but you also got pumps. When you think about quarry and mining, I mean, you're in the deepest depths of the earth, mining and quarrying, for these products. Water is a main, opposer to you day in, day out. You get springs, you get natural springs. You have, if you're like within 5 or 6 miles of a river, when you get below that river bottom, if you got fissures in your rock coming into your quarries or mine, that river water is going to steadily, continue to infiltrate into your production. So pumps are a main priority, to keep your working facilities in an operational mode, to keep the water at bay so you can continue to do your work.
So how much I need to know about that or consider that kind of depends on, I guess, the nature of the project and what my role is.
Well, that would be Jeff G's expertise.
Yeah, I mean, if you're in a larger construction project, if you are involved in the electrical phase, my recommendation would to seek out a reputable company that has professional engineers on staff that can do things like coordination studies on your equipment. They can do the types of calculations that you'll need to understand to have an intelligent conversation either with your general contractor or with the local utility company. And also, when it comes time to actually program the devices that are going to operate this facility, that coordination study will also provide you with the types of parameters and settings you need for it to operate safely. In the event of some type of hazardous condition, you want your breakers to operate, or you don't want to fry your transformer, or fry your equipment on site.
Well, and like what a lot of people don't realize is like these quarries and mines, you've got to coordinate those with your local utilities because a lot of those take the same kind of power needed as what a small town would take. I mean, yes, you're only operating like 40, 50 maybe employees, but your equipment and stuff has such a great demand in your lighting, your pumps, and other stuff we talked about. It may require a mass amount of electricity to be able to operate that for a very low manpower operation.
And I would say each segment has its own challenges.
Right.
You look at like medical, for example.
Oh yeah.
I mean, obviously, you need to have a good backup power strategy with generators, something like an auto throw-over scheme or an automatic transfer scheme. Now, and as someone in the construction world, you may not be the one responsible for that, but it doesn't hurt to understand that, like if you're building a hospital, there better be a pretty stringent application of backup failure in the event that power goes out.
Right.
Or, if it's one of the big tech companies, one of their data centers, they've got usually something like 99.9% uptime requirements. Like if Facebook goes down, something has gone terribly wrong.
Yeah.
Not because we all love Facebook, but because the people that design those systems, they've agreed with their clients that
We got to have this.
we're going to have power, we're going to have internet connectivity. Our uptime is going to be a minimum specification. And so their types of power that they get, they're going to have backups as well, generators. They're going to have automatic transfer schemes. But on top of that, they've got so much nonlinear loads like computers and servers that puts a huge burden on the power coming in from the utility. So oftentimes the power that they get from the utility company, once it comes into like a data center, for example,
has to be boosted.
well, they don't just boost it. Sometimes they drop it, they boost it, they clean it, they do whatever they got to do to it. Because, power, if you look at it, it's just a sine wave, if you remember back from, but the uglier your power is, or the dirtier it is, the less pretty that sine wave gets.
Yeah.
And I can tell you from experience, servers, any non-linear equipment, so like a light bulb is considered like a linear type of equipment, but something like a drive or a motor or a computer program, a computer server rack, whatever it may be, it draws nonlinear loads, and that makes the power get uglier and uglier.
Yeah.
So you have to clean that up. Otherwise, your efficiency is heavily reduced, and it applies that same issue with other people on the utility as
Go
well, or
into
on
a
the
little
same
more
grid.
depth about that. Your power load hasn't changed, but what you talk about cleaning it up to be able to make it more efficient.
Yes.
What's the difference in them?
Okay, so for example, let's say
Because it's not taking any more demand.
well, yes and no. So the utility company is going to agree with you some certain minimum cleanliness of power.
Right.
And they call that a power factor.
Right.
Okay, and they're going to say, you need to be above 85% power factor. So it's a 0 to 1 decimal value, but you can represent it as a percentage as well. So if you say your power factor is a 1, that means you have absolute perfect power. But that doesn't exist in the real world, right? Oftentimes what you get from the utility is going to be less. It's going to be somewhere in the 90 or the 0.9 or the 0.95 range. And then once it enters your facility, it's already gone through several pieces of equipment. Other consumers on the grid are applying their own.
So now you're down to 0.70, 0.75.
You're dropping, now you shouldn't be down to 0.7 in the U.S. because we have certain regulations, but certain parts of the world for sure.
Yes.
But what that means is that, let's say I need 10 amps, we'll just use some made up numbers. If I need 10 amps of 120 volt power to power my equipment, and I'm getting that power from the electric company, but my power factor is only 0.7, I'm actually going to need 0.3 more than what they're giving me.
Yeah.
So my demand is going to draw in greater, right? It's creating impurities in the grid, and it's also causing me to have to draw more power to run that equipment, and it's not good power either. So it could be damaging the equipment in the long run as well.
Because it ran on a lower voltage than what you actually need to run.
That's right.
Yeah.
I feel smarter just listening, y'all. It was a good conversation, y'all.
That's
Thank
Jeff
you.
T. Yeah.
I know it.
Thank you, guys.
That's cool.